Right, well, maybe we'll go ahead and get started then. So thanks everyone for coming today. My name is Steph Chat. I am the communications coordinator here with EMI Canada. And today we are going to have a presentation from Ryan Williams, our international projects manager, all about a trip he went on to Jamaica for the Hurricane Melissa disaster response. If you have any questions, you can go ahead, you can raise your hand, you can write in the Q&A, or you can go ahead and just write in the chat. And the chat also has a link that Ryan put in for updates from Water Mission as well. So we'll just start off in prayer here and then we'll get started. So God, thank you so much for this day. Thank you for this chance to come together and to learn about the incredible things that you've equipped us to do in this world to help others and to just spread your mission and spread your love. So thank you, God. In Jesus' name we pray. Amen. Just a reminder also that this will be recorded and posted after if you want to watch it again or if you need to leave or want to share it with anyone. And I'll pass it over to Ryan.
Awesome. Thanks, Steph. Well, I have the great privilege of sharing my experience deploying to Jamaica in December and January of 2025, 2026 in response to Hurricane Melissa. And it was in partnership with Water Mission, their disaster response team. And so, yeah, just thought this would be a good benefit to our community to kind of hear some of the work that EMI Canada is doing abroad in partnership with other great organizations, but also from a technical standpoint of like what I learned being on the ground and doing the work as a civil engineer. So feel free to stop and raise your hand, ask questions along the way. I do not mind being interrupted. So let's go. All right, so just a little background on Hurricane Melissa. It occurred on October 28th of last year. It hit Jamaica with a Category 5 hurricane, which is the highest category on the scale. It's basically anything greater than 150 miles per hour. It was the strongest hurricane to hit Jamaica, and it caused almost 41% damage to the country, almost about $9 billion in damage in just one day. And so quite devastating. And you can kind of see the path there that it took. It did not take very long for it to go from a tropical storm to Category 5. You can see how quickly that turned. And of course, Jamaica, where it stands in the Caribbean in relation to some of the other islands. So here's a little recap from the news of the hurricane. So we can go ahead and watch this.
Jamaicans are picking up the pieces days after Hurricane Melissa made landfall as a powerful Category 5 across the Caribbean. The storm is blamed for at least 28 deaths. That number is expected to rise.
Jamaica's prime minister says that the winds tore the roofs off of about 90% of the homes in the town of Black River, calling it ground zero. Schools have been destroyed and homes and businesses turned into rubble. The island's international airports are resuming operations, allowing relief organizations to fly in supplies. Residents in eastern Cuba and also in Haiti are facing some massive recovery efforts as well. Piece of good news is Melissa is no longer a tropical system. Just this monster area low pressure just past Newfoundland. It's going to go between Iceland and the United Kingdom over the next couple days. But I want to kind of recap Melissa. So it was tied for the third strongest Atlantic hurricane. It was the latest Category 5 on record in the Atlantic. It was the strongest ever to hit Jamaica, and it was tied for the lowest atmospheric pressure and winds at landfall. And this is the track as it went through over the past week, and it made that first landfall in Jamaica on October 28th at 1 p.m. with wind gusts near 200 miles an hour. They made that second landfall in eastern Cuba as a Category 3 with winds of 120.
Gusts of nearly 200 miles an hour?
Yes.
Hard to comprehend.
Well, Category 5 starts at 157 miles an hour, and after that, everything's Category 5. So it had sustained winds of 185 with gusts of 200.
And this just fueled it with all that warm water.
Yeah, because it actually went from a tropical storm into a Category 5 hurricane in very short order.
So yeah, that's just a little recap. And so when we got on the ground, you can actually see some of the photos of some of the devastation. Definitely when you're traveling, you're basically seeing down power poles wherever you go. Some are blocking the road. Just a tangled mess everywhere. A lot of the churches, a lot of the roofs were blown off, and so yeah, it was quite devastating. And so the rebuilding efforts will take quite a long time. This was one church that had their church sessions basically under a gazebo, temporary tent, because the roof on their church was blown off. Also, the damage not to just the buildings, but also to the trees. Many of the trees' leaves were all blown off. Now, this photo, kind of on the bottom right, was taken about a month after the hurricane, and so you can see some of that vegetation was starting to grow back. But definitely, for those that were on the ground immediately after the hurricane, it looked like a bomb had just gone off. This here is kind of a zoom in look at Jamaica, kind of on the western side of the island. And so the line in red is sort of the path, the eye of the storm of where that route took. And so a lot of those bookmarks that you see is um, the water mission points that we were either doing distribution work or had our production sites throughout Western Jamaica. And so you can kind of see most of our efforts were focused on the parish of Westmoreland. And so that's the very west end of Jamaica, which was the hardest hit. So you can kind of see in that news report, Black River kind of is just to the right of that red line. That was kind of ground zero. And so you can see a lot of our work and efforts were kind of focused in this area where most of the devastation took place. You can see in Westmoreland, there's a place on the very west end, which is called Negril, which is a very touristy location along the shore. And so that kind of was the original first base for our team, which we then moved closer to our sites, still along the shore on a place called Little Bay. And so you can see there was because our efforts were, trying to put in water treatment systems and distribution sites. There was a lot of travel in country, and so that tended to be the most dangerous part of the job. This here, just focusing in on some of the production sites that we were able to commission. This particular site was called Bluefields, which was just, if I go back to this site, I don't know if you can see my mouse, but it's kind of in the center region of Westmoreland along the shore. And so that's where this site is located. And you can see one of the things that really surprised me about Jamaica was that how clean the source water was. Jamaica has some of the cleanest source water in all of the Caribbean. And so you can see the existing National Water Commission, NWC, were using this site as a water production site for the local community. But because after the hurricane, basically all the power on the entire island was taken out, especially in places like this. Those sites were no longer in operation. And so a lot of the efforts that Water Mission and EMI Canada was doing was to help bring emergency clean drinking water in lieu of these sites being offline. And so our team were going out each day to assess potential treatment sites, and so this was identified as one of them. And so you can see what was great is that the local community understood that because this was a clean drinking water site, a lot of the bathing and a lot of the community activity was happening downstream. So you did have people bathing and cleaning clothes and that sort of thing, but it was everything that was downstream of the weir, that concrete kind of structure in the middle there. And so kind of this is just a zoom in of our efforts. We had basically deployed two Grundfos SQ10 190 pumps. So these were submersible pumps, basically in the in the stream. You can see how clear the water is. You can literally see to the bottom of that stream, which indicates in engineering terms we call that turbidity, or we measure it in units of NTU. And typically in an emergency setting, you want to have a water source that has less than 5 NTU. That is ideal. This water that we tested was less than or around 1. So you can just see this how clear that water is, and that definitely helps in the filtration or cleaning process of the water. So some of the stats, you can see the capacity. We were basically flowing at about 30 to 45 liters per minute. And so our total production at this site was one of our largest production sites, was about 120 liters per minute, or about 32 gallons per minute. And so this is a picture of that production site. So basically the water, we'll go back to this photo, the water that's collected from these pumps, you can see is then transported to the living water treatment systems kind of in the back there, though you see those clear whitish water tanks. Those are called the living water treatment systems, and I'll go in a bit more detail of those systems. But you can see the production and storage capacity of Bluefields was about almost 40,000 liters. And so, at the production rate that we had for those two pumps, we could basically fill this entire production site in about 5.4 hours, which was great because then on a daily basis, we had trucks coming in each morning that would fill their tank and then travel to each of our distribution sites to deliver the clean drinking water that was being produced at this site. And so, yeah, it was just a great process of not only producing the clean drinking water, but then storing it, and then also transporting it to each of our different sites. We couldn't have done this without local support, and so this particular site was located on a church property. So we had been partnering with many church ministries in the country and kind of using their sites as production locations. So we had a local operator. Her name was Jillian, and so she would be out on site each day, monitoring the system, turning valves, making sure the pumps were on, the generator, keeping and notifying us of each of the each of the values when the truckers would show up to fill. So it was very a smooth operation as far as like the data collection side of things as well. Oh, and I should also mention we did have a water tap here, so people would either drive their cars to the site or walk with their water jugs and fill directly at this site as well. This is just a quick schematic of the actual living water treatment system itself, and so you can basically see it's essentially a water treatment system on a pallet. And so it's got everything you need from it to basically take source water and clean it for drinking water. So you've got an alum tank, which helps to flocculate or help to create flocks to take the sediment out of the water with your alum tank. You've got a water filter as well, and also a backwash tank, which is very handy. So, depending on the turbidity of the water, you would turn a valve, which is, if you can see my mouse button, it's basically this handle right here that you would pull, and that would reverse the flow. That would help you to clean the filters each day to ensure daily operation. And so the local operators would be trained on how to use the system so that they understood all the different valves and knobs to operate it correctly. Um, you had a chlorinator as well. And so these dials up at the front would basically monitor the flow rate and the chlorine dosage rate into the water. And so one of the things as a civil engineer and as part of the commissioning of each of these systems is to make sure that you're dialing in the right level of chlorine into the water to make sure that you're not getting people sick, but also that you're putting in enough chlorine to disinfect any bad pathogens that are in the water as well. So the one thing about these systems though is once they get in operation, if you have to move them, they are quite heavy. And so that was probably one of the biggest challenges, was trying to move these units in the back of a truck. It was not easy. You'd have up to 6 to 7 people just try to lift up one side of these things. Here's some of the stats straight from the Water Mission site as well. So Water Mission are producing these units and then basically delivering them out, in this case to Jamaica, and then we would take these units and deliver them to our production sites. And so you can see they're basically pretty durable. They're designed to operate for up to 20 years and very low tech. Um, basically everything is hydraulically run with the help of either solar or maybe a small generator to run the submersible pumps. This was another site. So we had Bluefields and we also had Ferris Cross. Ferris Cross was one of our larger sites as well to produce water. We actually had implemented solar panels and a Tesla battery pack to run the pumps on this system. So we did not use a generator at all, which was great. We had you can see the four levels of solar panels that we had there. We had plenty of solar power to run the pump plus more. And so we had up to 3 LWTSs, I'll call them, living water treatment systems, at this site, as well as about 32,000 liters of storage capacity. The flow rate was a bit lower because the submersible pumps were not as large. They were the SQ130s. And so your flow rate was only about 6 gallons per meter compared to the 32 that we had at Bluefields. So the hours to fill was about 7 hours compared to the 5.4 at Bluefields. We had a local operator. His name is Dwayne. And so at this site, you could see we had basically our storage facility. And so all our pipes, all our pumps, all our generators, all our PVC tube, our fittings, our tools, everything was stored at this site. And so Dwayne kind of acted also as like security to make sure things were kept here. So this would be a place that we would basically drive from our base to Ferris Cross, pick up any supplies that we needed, and then go out to all the different sites from here. So this kind of acted as a base of operations for our team. Another site we had, which was probably the most challenging, which was closest to Black River. You can see it was just very, very close to ground zero. This was an aggregate site. You can kind of see in the bottom left. This is where they were producing gravel and sand for construction. And so they had an existing borehole that they were using. At one point, they were using it for drinking water, but then when we arrived, they were using it only for basically manufacturing and the production of the site. But the challenging point we had with this is we were able to tap into the existing line there, but it had a high copper level, which according to WHO standards should be less than 2 milligrams per liter, and we were getting about 2.8 to about 3. And so we had to try to find a way to get the copper below 2. And so we instituted in the top right, you can see some activated carbon and microfilters to help reduce that copper to about 2 milligrams per liter. So yeah, this was an interesting site. I learned some lessons here about just the chemical aspect of testing and making sure that some of the other secondary features of clean drinking water are also dealt with. Now, copper is, we would call it a long-term health effect, meaning that in the short term, especially in an emergency setting, it's not the end of the world if it's higher than 2, but you still want to meet these targets as best you can. And so even in an emergency response, we are taking steps to do what we can to reduce any sort of secondary effects. Then as for the truckers, we did hire on contract some local Jamaican truckers. And so what was great about these guys is that they were basically the backbone, of getting the water to the different distribution sites across Westmoreland. So we had About Time, Russell, Chris, O'Dane, and Hugel, each with their different trucks. About Time was definitely the largest. His tank was about 20,000 liters. And so he was able to fill quite a number of tanks each day. So these guys each morning are coming to our production sites, filling the tanks, and then heading out to all the different distribution sites to fill each of the tanks. And so I have a graph later that shows how much clean drinking water we were producing on a daily rate. But it was quite impressive, the operation that we were able to support. It goes to show that it's not just the civil engineering side of things, but it's also the operation side, making sure that these guys are getting paid each week, but that they're obeying the contract as far as delivering only water mission water. One of the things we realized about truckers is that if you know, they do deliver river water that's not disinfected, and so making sure that these guys are exclusively delivering clean drinking water ensures that you have a clean water source directly from the source water all the way to the tap. And so we ensure that people are not getting sick. The drivers were also trained in doing free chlorine tests. And so you can see in the top middle photo, they would have the color wheels and basically determine what the free chlorine levels in the water they were delivering each morning. And so that all that data was being tracked through the M Water system, which I will get to soon. As far as the distribution sites, we had a total of about 32 sites across Westmoreland that was serving about 58,000 people per day. And that was based off about a 3 liter per person uh, calculation. Uh, and so you can see the different photos. Definitely the appreciation that we received from the local Jamaicans was definitely heartfelt, understanding that everyone needs clean drinking water, and so just providing this basic service to people, you can definitely feel the appreciation for the efforts for our efforts and reaching a lot of these rural and kind of more out of the uh, off the main road, uh, hard to reach areas of Jamaica. And then kind of the life of a DR volunteer, a lot of travel, a lot of driving around to each of the different sites. Sometimes, going inside the water tanks, you got to clean out any mold or mildew that's maybe in some of those tanks. You're putting in the submersible tanks and connecting all the tubing and the electrical. You're transporting the black storage tanks around the country on the roads, which are, you know, you never know what will happen on the road. When we were there, we had actually a number of Canadian electrical vehicles there that were putting up new power poles along the main road, and so sometimes you have to get detoured away from your location and spend like an hour trying to get around a certain location, and so you just had to deal with that as it went each day. So we did have GPS and Starlink set up in each of our trucks, and so that was just a nice safety feature, making sure that everyone knew where everyone was. We had access to data and communication. Obviously, it takes a team to do something like this, and so in partnership with Water Mission, you can see some of the teams that we were able to work with. Because it was over the Christmas holidays, there were quite a number of people that were coming and going over that time frame, and so yeah, it took a lot of people to make sure that these systems were kept in operation, that clean drinking water was being delivered to all the people. And so yeah, just to really appreciate and thank you to all the members that were there, and the efforts of each of them. You can see also kind of at the top left some of our accommodations. It was quite nice. We were right on the beach, and so having on our days off, being able to go snorkeling or swimming or kayaking out onto the ocean was really a nice respite because it was long hours doing a lot of hard work out in the sun. So it was nice to have a place to relax and eat good food. Another aspect, I know Water Mission, they do have a living water program as well. So not only were we providing clean drinking water, we were also partnering with a lot of the local churches with beyond disaster training. And so we would train up local pastors and different communities on how to deal with the trauma after the hurricane. If you can imagine, a lot of people are dealing with the loss of everything, either their home or their everything that they own. It's all gone, and so a lot of these pastors are having to deal with the trauma of that in their communities. And so the Living Water program really helped to strengthen and to inform pastors on how to deal with that. And so yeah, we partnered with about 28 different churches across Jamaica. Another effort, and this is kind of for the uh, assessment side of things, we were working with the Jamaican authorities. The National Water Commission requested that we help them assess their rural water supply. And so we would go out to quite a number of different sites kind of in the interior mountainous region of Jamaica. A lot of these areas are only supplied through the use of basically storage of rainwater. And so you can see on the top right, kind of what these systems look like is basically a concrete pad on the side of a hill that would direct the flow towards a cistern in the middle. And that water would then be either treated with a filter or chlorinated in some cases, and then have like a tap house next to a road where people could take water. But you can see that some of these were damaged in the hurricane. And so I know as part of the work, Water Mission had identified up to 5 of these sites where we could help the NWSC repair some of the fences, clean up some of these areas, and get them back in operation. Another aspect of the disaster response was collecting data. One of the things that can be difficult and challenging in a response is to get clear data and information to make decisions. And so basically, Water Mission used a system called MWater, which was developed out of the USAID program. And this basically is an online platform that allows you in the field to use your phone to collect photos, to collect water quality data, um, basically everything, and then store it in the database that can then be analyzed and reviewed, and then decisions can be made based on that data. So it was a great place to go to yeah, just to review information. So this kind of is a snapshot of the front page, but then you can also pull out information like this that show kind of the cumulative flow rate over time. So you can see the kind of the initial start was back in early November, almost literally the day after the hurricane, as the team did assessments and then brought on these production sites online. You can see over time how much water we had produced, almost 1.7 million gallons of clean drinking water over a period of months, which is pretty awesome. This is how this data was collected. We would have basically a flow meter that was connected to a GPS data transponder. And so each of these LWTSs would be transmitting the flow rate each day that was then being tracked through MWater. We could also track our water quality tests. And so that purple graph can see kind of where the free chlorine data was being collected. And so you can identify maybe some that were too high or too low and make decisions accordingly. But it was also useful for tracking inventory movements. So if you are moving water tanks from different sites, you could track inventory that way as well as just the day-to-day trucking operations of how much to pay each of the truckers for how much water they transported. So it was just a really great tool. One of the challenging sites was Darlaston production site, which was decommissioned kind of the day. I think this was the first day of work for me was decommissioning this site. And so we worked with Jamie Shotter, who was another engineer, to decommission this site. The turbidity was only 2, but there were basically it was a farm pond, and that farm pond was receiving effluent from toilets and septic tanks. And so the turbidity was far more severe at the pump source. They had tried to alleviate that by raising the pump a bit from the bottom of the pond, which did help, but it still was quite complicated in that we had to employ a complicated treatment system that employed reverse osmosis and activated carbon filters that in the end we decided to decommission and then move. So basically our solution was to decommission this site, reposition the LWTS at Bluefields, which had a good water source, and then truck the water to Darlaston instead. You can see this was a outline of the PNID diagram of the system at Darlaston. The challenging part was that we could not use the chlorinator on the LWTS because if we did so, it would damage the reverse osmosis units, which were after that. So we had to basically chlorinate the water after the RO units and manually dose it at the tank itself. So it's a bit more involved as far as having the local operator do that each day. Now, another aspect of our work was doing water quality testing, and so we were able to use a lot of Hatch electronic units. So we had the Hatch D900, the Hatch 2100Q for turbidity, and the Hatch Pocket Probe for pH. We were also using the Colitag for presence-absence test for E. coli. And so these would be done basically at the commissioning of each LWTS, and then also done on a per monthly basis for the chemical tests to determine, the ranges and levels for each of the factors. And so this was kind of an outline of the actual, like I would say, the bottom requirements. The four big ones: E. coli, free chlorine, turbidity, and conductivity. So these would be tested, as you can see, the frequency there. We'd be testing the free chlorine every 24 hours. And then there were also tests for the chemical, such as nitrates and fluoride, arsenic, iron, manganese, etc. And as I had mentioned before, copper was one of the things we had identified that was above that acceptable test results range of 2. And so, again, these are just great kind of ranges to understand like what quality of water you're dealing with. I guess finally, lessons learned. As a civil engineer on a response like this, I did learn a lot. It was a great experience. I learned about the country of Jamaica and how respect is not something they just say, but they actually mean. So we took this photo in the top right, kind of what it actually means. So I learned about that. I learned that vehicle travel can be quite the adventure. I know our team had dealt with a lot of flat tires, even dead animals on the road, and just trying to navigate very poor remote roads that were washed out. It can be very challenging. The LWTSs were quite heavy, so you can see the photo in the kind of in the right middle there. Trying to get that thing onto the truck was quite the yeoman's work. It was quite hard, but we got it done. Um, One of the things I think a good recommendation is we only had like basically 2 pumps to choose from, and so that made it quite challenging in trying to deploy. Sometimes the range of those pumps, the flow rates were a bit low, and so that kind of reduced our ability to produce more water. But yeah, I think overall, yeah, I think it was a great trip. I learned a lot. So I think if this is something that interests you, if hearing about kind of my experience with EMI and water mission as a civil engineer, and this is something that you feel that you want to maybe do in the future, um, uh, there are ways that you can get involved. So you can kind of see some of the ways that EMI, not just civil engineers, but architects and structural engineers too, um, some of the things that we do in our disaster response. We do needs assessments, WASH, kind of what we did, but also evaluating buildings after earthquakes, floods, uh, monsoons. Like there's all sorts of disasters that do happen, and having a roster of engineers and architects that are available to respond is definitely valuable. So I'd say if you are interested, there's a QR code that you can scan. You can also go to that website and you can register um, to join the roster. So there are a number of trainings that are required before you mobilize, but I'd say pray about it, and if you're interested, definitely seek this out. So I think with that, if there's any questions, I'd be happy to answer them. I know that was a lot in 36 minutes.
Thanks, Ryan. I think that was excellent. Thank you. I do see Steve Brooks on the call today. Steve, I'm not sure if you're. There you are. That's great. Good to see you.
Good to
As
see
always,
you, Greg.
we don't often get a chance to.
Yeah, it's been a while.
We do. It's always a pleasure. So, for those who do not know, Steve has been connected with EMI for many years, in many volunteering capacities, but is also, I think, very notably on our global board and has been a part of that. And I guess ultimately my boss, I guess. So, but he's provided much of his expertise over the years, to EMI. So Steve, I'd love to hear kind of. Thanks for joining us, by the way. Love to kind of hear just your thoughts on this, and for those of you again who don't know Steve, and you may be very humble and may not say too much about yourself, but Steve was and Oz Architects in Denver, of which is a partner, I believe. Yeah. You've done the city master planning for cities like Kigali and others, and so you've had a lot of international experience, very large scale, but also being involved with EMI on smaller scale kinds of deployments. So, Steve, would love to kind of just hear your thoughts on what Ryan presented today.
Yeah, well, thanks, Greg. One correction, I did start my own company, Urban Planning Constellation, to focus on international work. Since I was doing mostly domestic work, I decided to go out on my own. But I am really excited about disaster relief, and I know it's kind of one of those things that's difficult to staff in a way, because you never know when something's going to happen and when the resources need to be pulled. But to me, it's a really exciting arm of EMI, and I really appreciate learning what happened there in Jamaica. I think it's pretty exciting. I did have a question. I was wondering what kind of reconnaissance. I'm assuming there was a reconnaissance trip that before all of this took place, and I'm wondering what are some of the things that have to happen in order for you to get in country and get all of this accomplished. Then my second question is, how is all of it financed? What were the sources of revenues to get that work done?
Mm-hmm. I think I could speak to kind of the initial. I believe, again, the water mission would know more than I, but from what I was told in country, they had a number of people actually there during the hurricane, but in Kingston, which is kind of on the eastern side of the island. Water Mission, I know, has a agreement with UNICEF, and so they have been servicing disaster response through a separate contract. And then Jamaica was kind of lumped in with that after this happened. So a lot of the funding, and to answer your second question, a lot of the funding came through UNICEF. So UNICEF is kind of that overarching umbrella, and then kind of we're working under them. And so one of the photos, which I'll go back to. On this one here. Sorry for the scrolling. Top right, UNICEF did visit our sites on a number of times to kind of see our progress, what we were doing, and so they were heavily involved in obviously the approval of our scope of work, what we were doing. There were 3 phases of it. So there was phase 1, which was the initial phase of reconnaissance and assessment. Number 2, phase 2 was kind of that assessment side, helping out the National Water Commission with their rural water supply, and then also continuing the production of the clean drinking water. And then phase 3, which was kind of January, February, continuing what we were doing. There was also a handoff back. There actually is a handoff happening at the end of February here, basically handing the system back to UNICEF and local supporters to handle these systems after Water Mission leaves the country. So there's kind of all of that was going on behind the scenes as we were doing the work. And so Hannah Baker, she was kind of the water mission team lead. She was handling a lot of those conversations with UNICEF and getting the approvals. So it was very, very closely tied to not just, we were not in a bubble. We were working very closely with the local authorities and government in our work.
Great, thank you.
Ryan, do you see any other phases or any other like specific aspects of the execution of this that would bring EMI back to this specific deployment, or what other scope might we be helpful with?
Yeah, probably not. I think there's definitely was a conversation um, in that it's funny, the water we were producing in Jamaica was probably cleaner than the water they're getting from the local National Water Commission. So there's an aspect of, do you want the local people to rely on our systems
Mm.
long term? It's like at some point you do have to hand it back to the local authorities. And so, but we do know like it is going to take a long while because of how much damage was caused to the country. Um, so that's why I think that handoff to UNICEF and local supporters is very important in that the people don't become too reliant long term with what is like an emergency response, and that can always be a very, very delicate conversation, and with the community even of like, oh, you're leaving us, what do you mean you're leaving, you're right. It can be very challenging to not have that permanency of the systems. So I know a lot of those discussions were happening as well. Um, but I think, yeah, long term, a lot of the work is winding down at this point and being handed off at the end of February.
Right. So there will be a decommissioning
Yes,
series
either
of steps.
that's right.
Right? So,
I think the conversation was either a storage of some of the units, so decommissioning them, storing them
mm,
for the next hurricane, so they have those on hand. That
wow.
was one potential. But again, that's depending on who has the authority to do with what the systems to do, what they want with the systems. We'll see. I know Water Mission did post an update on their website, basically just saying that they let me find it here. They're handing over operations to UNICEF Jamaica and local system operators by the end of Feb. So that's the plan.
So would it be fair to say that UNICEF then is now thinking of other partners, like bringing in the health education piece and things like that, that kind of communication, how to that's really then a couple steps up. That's really a UNICEF kind of responsibility, I guess, for the overall project. Yeah,
That's right. Yeah, and it depends on their budget and what their priorities are.
great. Thank you.
So is Water Mission kind of in the habit of calling on EMI when additional manpower is needed? I'm assuming that's why EMI got called, is that they probably don't have the staff to handle a big project by themselves, since it's one of those things that comes and goes.
Correct.
Is that the way?
Yeah. It was we have a memo of understanding between Water Mission and EMI, and so the benefit there is they do have a number of engineers on staff, but definitely not enough to cover the more specifics like in this response. And so having that ability to call on EMI for civil engineers definitely, I think it's a win-win for both, right? In that we were able to provide two engineers. Myself, I went, but also another gentleman, Bob Eink, also went. And so we were both there to help out with the assessments and the commissioning of these systems.
I see Wesley Tse up in the upper
Yeah.
right. He's also serving on the global board of EMI.
Yeah,
Right.
correct.
He wears two hats.
He wears two hats, yes.
He's
was
worn
there.
a lot of different hats over the years.
He
Yeah.
was there. He left, I think, the day after I arrived. So we were kind of like two ships passing in the dark. But he was there, kind of at the initial first phase of the deployment.
So, Steve, I think you would find this really a cool fact, a fun fact that Wes was an EMI Canada intern in 2007. That's how he got involved with EMI. And Ryan was a double intern 2008, 2009 with US and Uganda. So these are people who've stayed within the sector and have done amazing things. So it's really cool to see so many of these really come full circle. And these are hardly, young people without experience anymore. These are people we're deploying to lead these kinds of initiatives. And so I think that's really exciting.
Yeah,
So,
very cool.
Yeah, and Ryan, I think you might agree with me on this one too. Is that with a lot of groups like Water Mission, Food for the Hungry, Samaritan's Purse, and others, they're very good at putting together projects and initiatives. But because those are not necessarily an everyday thing, it's very hard for them to keep practicing engineers sort of on board all day, every day. And that's really where the strength of EMI comes in, is we're able to respond to these kind of deployments very quickly, whether with staff or with our volunteer base, which of course, is in the many hundreds of and into the thousands. And so I think these kind of partnerships are perfect. Yeah.
Mm-hmm. Yep. And
So
it's a lot of relationship building too. I mean, I think I can speak. A lot of the Water Mission staff acted very professionally and worked. Were really good at their jobs, and so being able to build relationships with each of them as well was also a great aspect for me. Knowing that in the future, if they call again, they want me back. So yeah, I think it's just overall a win-win for both.
And I think having EMI on the ground also is eyes on the situation for other development projects or relief projects that could come on after the emergency relief.
That's right. Yeah, a lot of churches, like I said, were damaged, and so roofs that have to be replaced and whatnot. So definitely.
Any more questions from anyone? All right, well, thank you all so much for attending, and thank you, Ryan, for sharing about your experience. For everyone who was here, thank you again. And for anyone who's watching this after and watching the recording, I hope you learned something, and let us know if you have any questions about anything.
Great.
Thanks, everyone.
Thanks, everyone.
Thank you, Ryan. Appreciate it.
Thanks, Ryan. Good to see you, Steve. You take care.
Bye, Greg.